Close your eyes. No, seriously. Close them for 3 seconds, then open them. Now, quick question. Which direction did your eyelids move? Down, then up? Wrong. Your upper eyelids moved down and up, yes, but your lower eyelids? They barely moved at all. You've been blinking tens of thousands of times a day your entire life, and you probably never noticed that blinking is asymmetrical. This is how broken your perception is. And mirrors? Mirrors exploit this bug in your brain in the most spectacular way possible. Here's what I want you to do right now. Look at a mirror, any mirror, your phone screen when it's black, a window, anything reflective. Now touch your right ear with your right hand. Watch what happens. The person in the mirror touches their left ear with their left hand, right? The mirror swapped left and right. That's just what mirrors do. It's obvious. You can see it happening. Except here's the thing that's going to make your brain short-circuit. That person in the mirror is touching their right ear with their right hand, not their left, their right. You've been interpreting it wrong your entire life. We all have. Your kindergarten teacher got it wrong, the textbooks got it wrong, that one smart friend who explains everything definitely got it wrong. And here's the question that's going to haunt you for the rest of this journey. If mirrors reverse left and right, then why the hell is your head still on top? No, seriously, think about it. Your reflection's head isn't where its feet should be. The ceiling behind you didn't become the floor in the mirror. Up is still up, down is still down. So the mirror chose to flip horizontal but not vertical. Why? What makes left-right so special? Does the mirror have a preference? Is it discriminating against the horizontal axis? Or, and here's where reality starts to crack, what if the mirror isn't doing what you think it's doing at all? What if the reversal you've been seeing your entire life is happening inside your head, not inside the mirror? What if you've been blaming the mirror for something you're doing to yourself? Stay with me, because once you see what's really happening, you won't just understand mirrors differently. You'll understand space itself differently. And you'll realize that this simple bathroom object has been trying to teach you about the geometry of the universe this whole time. You just weren't asking the right question. Richard Feynman loved this problem, not because it involved complex equations or exotic particles, but because it exposed how our brains lie to us about the simplest things. When someone asked Feynman about mirror reversal, he didn't start with optics or reflection laws. He started with a question. What do you mean by reverse? This is classic Feynman. Strip away the assumptions. Question the question itself. Let's do what Feynman would do. Let's think from first principles. Imagine you're standing in front of a mirror. Now, instead of thinking about your reflection, think about what the mirror is actually doing to light. A mirror is just a surface that bounces light back to you. That's it. Light from your face travels to the mirror, hits it, and bounces back to your eyes, following one simple rule. The angle of incidence equals the angle of reflection. That's the only thing a mirror knows how to do. It doesn't understand left or right, or you, or text. It's just bouncing photons. So here's Feynman's crucial insight. The mirror doesn't reverse anything. You do. Wait, what? Let me show you. Stand in front of a mirror and raise your right hand. The person in the mirror raises their hand on your left side. But that person isn't you. That person is facing you, looking at you, standing on the other side of the glass. Now, here's the key question Feynman would ask. If an actual person was standing on the other side of that glass, facing you, which hand would they raise? Their right hand, which would be on your left. The mirror isn't reversing anything. It's showing you exactly what would be there if there was actually someone standing on the other side of that surface facing you. The reversal you perceive happens because you are unconsciously imagining walking around to the other side of the mirror and facing the same direction as your reflection. But that's not what's happening. Your reflection is facing the opposite direction from you. It's facing towards you, and that changes everything. Let's get into the actual physics of what's happening, step by step, because this is where it gets beautiful. When light bounces off a mirror, it follows the law of reflection. Theta I equals theta R. Angle of incidence equals angle of reflection. Both angles are measured from the normal, an imaginary line perpendicular to the mirror's surface. Picture this. You're a photon leaving the tip of your nose, traveling toward the mirror. You hit the mirror at a certain angle. You bounce back at exactly the same angle on the opposite side of the normal. You travel back to your eye, and your brain traces that path backward in a straight line, creating the illusion that there's something behind the mirror. This is crucial. Your brain always assumes light travels in straight lines. It doesn't know about the bounce, so it extends that final path straight back through the mirror, creating a virtual image, a place where light appears to be coming from, but isn't actually there. Now, let's think about what this does to three-dimensional space. Imagine a coordinate system. You're standing at the origin. Your right hand points along the positive x-axis. Your head points along the positive y-axis. Your nose points along the positive z-axis toward the mirror. The mirror is a plane at some distance along the z-axis, perpendicular to it. What does the reflection do to each axis? X-axis, left-right, a point at +5, 0, 2 in front of the mirror, creates an image at +5, 0, -2 behind the mirror. The x-coordinate is unchanged. Y-axis, up-down, a point at 0, +5, 2 in front of the mirror, creates an image at 0, +5, -2 behind the mirror. The y-coordinate is unchanged. Z-axis, forward-backward, a point at 0, 0, +2 in front of the mirror, creates an image at 0, 0, -2 behind the mirror. The z-coordinate reverses. Front becomes back, forward becomes backward. That's it. That's the only reversal happening. But wait, you're saying, that doesn't explain why my right hand appears on the left. Exactly, because that's not the mirror's doing. That's yours. Here's the thought experiment that makes it click. Imagine you're facing north, looking at a mirror on the wall in front of you. Your right hand points east, your left hand points west, your head points up, your feet point down. In the reflection, you see someone facing south, towards you. Their right hand still points east, the same absolute direction as yours. Their left hand still points west. Their head still points up. Their feet still point down. Every compass direction is preserved. Nothing is reversed except forward-backward, north-south. But here's what your brain does automatically. It imagines rotating that person 180 degrees so they face the same direction as you, both facing north. If you rotated them around their vertical axis, their right hand would now point west and their left hand would point east, the opposite of yours. But the mirror didn't do that rotation. You did, in your imagination. The mirror created a coordinate transformation called an inversion or improper rotation. Mathematically, it's a reflection through a plane represented by the transformation x, y, z to x, y minus z. Here's the mind-bending part. This transformation preserves distances and angles, but it changes handedness or chirality. Imagine your right hand. Your thumb, index finger, and middle finger can form a coordinate system following the right hand rule. No matter how you rotate your right hand, those three fingers maintain that relationship. Your reflection's hand, however, follows the left hand rule. Not because the mirror swapped left and right, but because the mirror reversed depth, which flipped the chirality of three-dimensional space itself.
If you could somehow step through the mirror into that reflected space, you would be living in a left-handed universe. Your heart would be on the right side of your chest, clocks would run counterclockwise, DNA helices would spiral the opposite direction. The mirror didn't just reverse an image, it created a mirror universe. Let me give you another way to see this. Take a book with text and hold it facing the mirror. The text appears backwards. Now, instead of rotating the book around its vertical axis to face the mirror, rotate it around its horizontal axis. Flip it upside down while keeping the front cover facing the mirror. What happens? The text is still backwards in the mirror, but now the book is also upside down in the reflection.
The mirror doesn't care which axis you used to rotate the book. It just reverses front to back, always. The backwards text happens because you chose to rotate the book around the vertical axis to make it face the mirror. If you had rotated it around a different axis, you'd get different results, but the front to back reversal would remain constant. Here's an even clearer demonstration. Write a word on a transparent sheet. Hold it up facing the mirror. From behind the sheet, from your perspective, you can read the word normally. In the mirror, you see the back of the transparent sheet and the text appears reversed. Now, walk around and look at the actual back of the sheet, not the reflection. The text appears reversed in exactly the same way. The mirror is just showing you the back. The reversal comes from looking at the back of something with writing on the front. Now, let's break reality. Imagine you're an ant living on a flat piece of paper, a truly two-dimensional creature with no concept of up or the third dimension. Someone places a mirror perpendicular to your 2D world, cutting through it like a wall. You approach this mirror and see your reflection. From your perspective, as a 2D being, the mirror has reversed your left-right axis. Your right antenna appears on the left side of your reflection. But you have no concept of front-back because you have no depth. You can't perceive the third dimension. But here's the paradox. In the three-dimensional space that contains your 2D world, the mirror is actually reversing the third dimension, the dimension you can't perceive. It's reversing up-down in 3D space. But because you only experience two dimensions, you interpret this as a left-right reversal in your 2D plane. Now extend this to us. We live in three spatial dimensions. A mirror reverses one of them, depth. But what if we're embedded in a higher dimensional space we can't perceive? What if the mirror is actually reversing something in the fourth spatial dimension, and we're interpreting it as a front-back reversal in our 3D space? Here's where it gets truly weird. Physicists have seriously considered this. In certain theories of physics involving extra dimensions, like string theory, our 3D universe might be a brain floating in a higher dimensional space. A mirror in our universe could be performing a reversal in that higher dimension. And here's the kicker. We would have no way to know. Just like the 2D ant can't perceive the true nature of the reversal, we might be misunderstanding what mirrors actually do because we're trapped in 3 dimensions. Now, let's take this further. Imagine a universe where mirrors reversed time instead of space. You look in the mirror and see yourself 5 seconds ago. Now imagine that instead of seeing the past, you see a universe where entropy runs backward, where coffee spontaneously heats up, where broken glass reassembles itself, where smoke flows back into cigarettes. This isn't as crazy as it sounds. The fundamental laws of physics, mostly, don't distinguish between forward and backward time. Entropy does, but the individual particle interactions don't. A mirror that reversed time would show you a universe obeying the same physical laws, just with entropy flowing the opposite direction. You'd see your reflection aging backwards, breathing in instead of breathing out, wounds healing before they're inflicted. And here's the paradox. How would you know that you aren't the reflection and the person in the mirror isn't the real one living in the forward time universe? This relates to a real concept in physics called CPT symmetry, the idea that if you reversed charge, parity, and time simultaneously, the laws of physics remain unchanged. A mirror universe that reversed all three would be physically indistinguishable from our own, which means somewhere in the mathematical space of all possible universes, your exact mirror image twin exists, living in a left-handed universe where time might run backward, and they're looking through their mirror, wondering the exact same thing. Okay, you might be thinking, this is fun to think about, but why does it actually matter? Let me tell you about thalidomide. In the 1950s, thalidomide was prescribed to pregnant women for morning sickness. It was considered safe, but it caused catastrophic birth defects. Thousands of children were born with malformed limbs. Why? Because of mirrors. Thalidomide is a chiral molecule. It has a handedness. It comes in two mirror image forms called enantiomers. The right-handed version helped with nausea. The left-handed version caused the birth defects. When chemists synthesized thalidomide, they created both versions. And the human body, which is also chiral, your organs aren't symmetrical, your heart is on the left, your liver on the right, responded to each mirror image differently. This is the direct, tragic consequence of chirality, of the fact that mirrors create fundamentally different versions of three-dimensional objects. Today, pharmaceutical companies spend billions ensuring they synthesize only the correct chiral form of medicines. The mirror image isn't just different, it can be deadly. This extends to everything. DNA is a right-handed helix. Left-handed sugars taste different than right-handed ones. The amino acids in your body are all left-handed, except glycine, which is achiral. If you ate food made of right-handed amino acids, you couldn't digest it. You'd starve surrounded by nutrition. Why? Because the enzymes that break down food are chiral lock and key mechanisms. The right-handed key won't fit the left-handed lock. Life itself is chiral, and we don't fully know why. Why did Earth's life choose left-handed amino acids and right-handed sugars? Was it random chance? Was it influenced by the chirality of the weak nuclear force, which does violate mirror symmetry? Could there be alien life somewhere using the opposite chirality? If we ever meet such life, we couldn't eat each other. We'd be nutritionally incompatible. It would be like trying to plug a USB cable in wrong, except biological. But the implications go even deeper. The violation of parity symmetry by the weak nuclear force means the universe itself isn't mirror symmetric. In certain radioactive decays, electrons are emitted preferentially in one direction relative to the nucleus's spin. If you watched this decay in a mirror, you'd see something that never happens in our universe. This discovery, made in 1956, shocked the physics community. For decades, they'd assumed the laws of physics were identical in mirror-reflected space. They were wrong. This has profound implications for cosmology. If the universe isn't mirror-symmetric, maybe that's related to why we have more matter than antimatter. Maybe in the first moments after the Big Bang, some subtle asymmetry, a kind of cosmic handedness, determined that we live in a matter-dominated universe rather than one where matter and antimatter annihilated each other completely.
Your existence might depend on the universe not being mirror-symmetric. And when engineers design quantum computers, they have to account for chirality. Certain quantum states are mirror images of each other, and the computer needs to distinguish them. The future of computing might depend on understanding what mirrors do at the quantum level. Even in navigation, GPS satellites have to account for relativistic effects, and some of those effects involve the handedness of rotating reference frames. The math of mirrors and chirality shows up in the equations that keep your phone's map accurate. The simple question, why don't mirrors reverse up and down, leads directly to the deepest questions in chemistry, biology, particle physics, and cosmology. So let's come back to you, standing in front of that mirror. You raise your right hand. Your reflection raises their hand. No reversal happened. The mirror faithfully recreated what would be there if there was someone standing on the other side, facing you. But something deeper did happen. The mirror created a place where chirality is flipped, where your heart is on the right, where you are your own mirror twin. It created a portal to a left-handed universe, not in a mystical sense, but in a precise mathematical one. Every time you look in a mirror, you're glimpsing an alternate geometry of space, a place where three-dimensional space has been turned inside out in a way that preserves distances and angles, but inverts handedness. Ancient Greeks thought mirrors captured souls. Medieval alchemists thought they revealed hidden truths. Victorian spiritualists thought they were portals to other realms. They were all onto something, not in a supernatural sense, but in a deeper one. Mirrors don't just reflect light, they reveal the structure of space itself. They show us that left and right aren't absolute properties of the universe, they're relationships dependent on orientation and handedness. They show us that the universe makes a distinction between clockwise and counterclockwise at the fundamental level. They show us that we live in a chiral universe where the direction things spin matters. And they teach us something even more valuable, that our immediate perceptions lie to us, that the obvious answer, mirrors reverse left and right, can be completely wrong, even when we're staring directly at the phenomenon. The next time you look in a mirror, don't just see your reflection, see a coordinate transformation. See an inversion through a plane. See a window into a left-handed universe where everything is almost the same, but fundamentally different in ways that matter for life, chemistry, and the structure of reality itself. See a reminder that the universe is stranger than it appears, and that the deepest truths often hide behind the simplest questions. The mirror isn't lying to you, it's telling you the truth about the geometry of space. You were just asking the wrong question. The mirror doesn't reverse left and right, it reverses everything else. And once you see that, you can never unsee it. The person in the mirror, the one staring back at you right now, they're not you. They're not even facing the same direction as you. They're your coordinate twin in a reflected universe, separated from you by a plane of inversion, living in a space where handedness runs backward. They're waving with their right hand. So are you, and nothing has been reversed at all.